Q7078-2. Initially, collective pitch should be lowered in an autorotation in order to A. Maintain the desired angle of descent. B. Prevent an engine overspeed. C. Prevent loss of rotor RPM. The correct answer is C. During an autorotation, the helicopter is descending without engine power, and the pilot needs to manage the rotor RPM to ensure a safe descent. The rotor RPM represents the rotational speed of the main rotor blades and is crucial for generating lift and maintaining control of the helicopter. When the engine power is lost, there is no longer a continuous power source to drive the rotor system. Therefore, the pilot must carefully control the collective pitch to maintain the rotor RPM within the appropriate range. Lowering the collective pitch initially helps prevent loss of rotor RPM. This is because lowering the collective reduces the demand for lift from the rotor system. With a reduced demand for lift, the rotor blades require less power and energy to maintain their rotation. By preventing loss of rotor RPM, the pilot ensures that the rotor system continues to provide sufficient lift for a controlled descent. Maintaining proper rotor RPM is essential for maintaining control authority and the ability to flare and cushion the landing during an autorotation. Lowering the collective pitch also helps in reducing the overall drag on the rotor system, which aids in preserving the available energy and rotational speed. 7089. When performing a touchdown autorotation, what action is most appropriate? A. Anti-torque pedals should remain neutral after ground contact. B. Skids should be in a longitudinally level attitude at touchdown. C. Aft cyclic application after touchdown is desirable to decrease ground run. The correct answer is B. During an autorotation, the helicopter descends without engine power, and the pilot aims to execute a safe touchdown. The touchdown phase is critical for ensuring a smooth landing and minimizing any potential damage to the helicopter. Keeping the skids in a longitudinally level attitude at touchdown is the most appropriate action. This means that the skids should be parallel to the horizon and aligned with the helicopter's longitudinal axis. Maintaining a longitudinally level attitude helps distribute the landing forces evenly across the skids, minimizing the risk of tipping or rolling over. It provides a stable platform for the helicopter to touch down and helps prevent any excessive lateral or longitudinal movements that can lead to instability or loss of control. A level attitude at touchdown also allows for better weight distribution and helps absorb the vertical forces during the landing, reducing the impact and stress on the helicopter structure. By ensuring that the skids are longitudinally level at touchdown, the pilot increases the chances of a safe and controlled landing, minimizing the risk of damage or loss of control. 7089-1. After coming to a complete stop following autorotation in a helicopter, what is the next step the pilot should take? A. Raise the collective. B. Lower the collective. C. Apply aft cyclic. The correct answer is B. After a complete stop following an autorotation, lowering the collective is the most appropriate action for the pilot to take. The collective pitch control adjusts the angle of attack of the rotor blades and determines the amount of lift generated by the rotor system. Lowering the collective reduces the pitch on all main rotor blades, effectively decreasing the lift being produced. In this situation, where the helicopter has come to a complete stop, there is no need for the rotor system to generate lift, as the helicopter is on the ground. Lowering the collective after coming to a complete stop helps ensure that the rotor blades are at a neutral or near-neutral pitch, reducing the chance of any accidental or unintended rotor-generated lift while the helicopter is on the ground. This action enhances safety and prevents any potential unintended vertical movement or lifting of the helicopter. Additionally, lowering the collective after stopping allows for a smoother shutdown procedure if the pilot intends to shut down the engine or perform any maintenance tasks. It provides a stable and controlled state for the helicopter while on the ground. 7072. If excessive right pedal is applied during an autorotative turn to the right, the nose of the helicopter will tend to A. Pitch up and the rotor RPM will tend to increase. B. Pitch down and the rotor RPM will tend to increase. C. Pitch down and the rotor RPM will tend to decrease. The correct answer is B. During an autorotative turn to the right, the pilot uses the anti-torque pedals to control the helicopter's yaw and maintain heading. By applying right pedal, the pilot increases the collective pitch of the tail rotor blades, which generates more thrust on the right side of the helicopter, countering the torque effect of the main rotor. However, if excessive right pedal is applied, it can lead to an imbalance in the forces acting on the helicopter. This excessive pedal input causes an increased thrust on the right side of the tail rotor and a decreased thrust on the left side. As a result of the increased thrust on the right side, the nose of the helicopter tends to pitch down. This is because the increased thrust generates a greater downward force on the tail, causing the nose to lower. Additionally, the rotor RPM will tend to increase. The increased thrust on the right side creates more torque on the main rotor system, which causes the rotor RPM to increase. The increased rotor RPM can lead to an overspeed condition if not properly controlled. 7073. Using right pedal to assist a right turn during an autorotative descent will probably result in what actions? A. Pitch up of the nose, increase in rotor RPM, decrease in sink rate, and decrease in indicated airspeed. B. Pitch down of the nose, increase in the rotor RPM, increase in sink rate, and decrease in indicated airspeed. C. Pitch down of the nose, decrease in the rotor RPM, increase in sink rate, and increase in indicated airspeed. The correct answer is B. During an autorotative descent, the pilot uses the cyclic control to initiate and maintain a turn. However, in order to maintain heading control and prevent the helicopter from yawing in the opposite direction of the turn, the pilot may need to use the anti-torque pedals, such as the right pedal for a right turn. By applying right pedal during an autorotative descent to assist a right turn, several actions are likely to occur. Pitch down of the nose. Applying right pedal increases the collective pitch of the tail rotor blades, which generates more thrust on the right side of the helicopter. This increased thrust on the right side causes the nose of the helicopter to pitch down. Increase in rotor RPM. The increased thrust generated by the right pedal input leads to an increase in torque on the main rotor system. As a result, the rotor RPM tends to increase. Increase in sink rate. When using right pedal to assist a right turn, the increased thrust on the right side can cause an imbalance in lift distribution. This imbalance can lead to a higher sink rate, resulting in a steeper descent. Decrease in indicated airspeed. As the helicopter pitches down and experiences a steeper descent, the indicated airspeed typically decreases. This decrease in airspeed is a result of the increased sink rate and the change in the helicopter's attitude.